Welcome to another practical of municipal wastewater engineering. Today we will be performing or estimating sulfate ions in any given wastewater sample. Before going into the practical, let us have a brief discussion on sulfate ions. Sulfate ions are naturally found in water. Also, excess amount of sulfate ions leads to laxative properties. Also, sulfate in conjunction with magnesium sulfate leads to more problem. Also, there are two critical points where handling and treatment of wastewater is become important regarding sulfate ions. First is the corrosion and second is the odor. So treatment of corrosion and odor in wastewater plant is very important. Next we come to the principle. The principle is pretty simple. Basically, sulfate ions reacts with barium chloride and forms barium sulfate. Now this barium sulfate will be using turbidity meter to find its value. So let us have a discussion on the reagents and glasswares that we are going to use. So first let us have a discussion on the reagents. We will be using barium chloride, and then we'll be using sulfate buffer solution. And then we have prepared standard sulfate stock solution. Here 1 ml is equal to 100 microgram, that is the concentration. We have our wastewater sample. We have our measuring cylinder. We'll be using pipette and we have pipette pump. We'll be using wash bottles, spatula and rod. For preparation of series, we'll be using stock solution. Also we will be using magnetic stirrer, as you can see. We'll be using the magnetic stirrer for 1 to 2 minutes. And then we'll be using our instrument turbidity meter, as you can see in the video, for finding this turbidity meter which we have already calibrated. After this, as you can see, we'll be preparing series for calibration curve. For preparation of series, we'll be taking standard stock solution of sulfate. So first we will prepare our series and then we'll go into the further process. So for preparation of series, the first will be blank. In second we'll be using 5 ml blank, 5 ml stock solution, 10 ml stock solution, 20 ml stock solution, and this will be used for 30 ml stock solution. Also we'll be needing one more. This will be for a sample. So first we will be adding stock solution using pipette. So using the pipette and pipette pump, we will be taking out 5 ml, 15 ml, 20 ml and 30 ml of standard sulfate stock solution. And after filling it with stock solution, we will be making it up to 50 ml of distilled water. So here we are adding 15 ml. So using pipette pump, we have prepared our series. So this is blank, this is 5 ml, 10 ml, 15, 20, 30, and this will be used for our sample. So now using distilled water, we are going to fill till the mark of 50. Similarly, we are going to make up 250. Please make sure we don't have to add 50, we have to make up to 50. So in this we are adding only 45, in this we'll be adding 40. So now we have taken, next we'll be taking 50 ml of sample. So we will be using measuring cylinder. We will pour the sample into this. So now our CVC is prepared. Now we are going to the next step. In the next step, we have to add 2 ml of buffer solution and pinch of barium chloride, and then we will use magnetic stirrer for complete rotation and mixing. So before using this, it is important that we must wash our pipette. So we'll be using wash bottles. We'll be washing the pipette using wash bottle. After this, we will be putting 2 ml of standard buffer solution or buffer solution in all of them. Okay, so now we have added 2 ml of buffer solution in all the series. Now we will be adding pinch of barium chloride, and after adding barium chloride we have to immediately go for magnetic stirrer. So using spatula, take this much of barium chloride. We'll be using we will wait for 2 minutes for complete mixing. So now after 2 minutes we will be measuring the turbidity. So we have this, it is already calibrated. So after filling till the mark, it is important to wipe it out properly, and then we will be calculating its turbidity. We'll press enter. I put the sample. So the value is 16 NTU. Similarly, now we will be doing same for first web series of 5 ml. So now it is important to wash it before filling it with another sample. We have to fill it till the given mark. So for 5 ml, which is equivalent to 10 milligrams per liter. So for 5 ml, the turbidity meter value is coming around. Turbidity's value is 58 NTU. Similarly, we'll be using for other concentration. After taking it out, it is important to clean it, wash it with wash bottle before filling it with another concentration. So now we'll be using for 10 ml of 20 milligram per liter. It's important to wipe it out every time. Kindly note down the readings. For 10 ml, the turbidity value is 95 NTU. Similarly, take it out, wash it. So now we will be calculating turbidity value for 15 ml of stock solution of 30 milligrams per liter equivalent. So it is coming 197 NTU. Kindly note down the reading. This is for 15 ml stock solution concentration. Similarly, for others, we will be preparing by adding barium chloride, pinch of barium chloride, and using magnetic stirrer. So this is prepared for 20 ml stock solution or 40 milligrams per liter. So for 20 ml of stock solution, we will find the turbidity value. This coming around 238 NTU. Kindly note down the reading for 20 ml. So now we have left with our last 30 ml and our sample. After 20 ml, we have a last for 30 ml. Kindly note down the reading for 30 ml or the value for 20 ml. For 30 ml the value is 304 NTU. So now we are left with our sample. Again we'll wash it with distilled water. So this is our sample. Again wipe it out. So the value in NTU for a sample comes around so kindly note down the reading, it is around 191 NTU. Okay. So after this, you will be preparing the calibration curve. For preparation of calibration curve on the x-axis, we will be noting down the value of turbidity in NTU, and in the x-axis we have already prepared different series of standard stock solution. So using both x-axis and y-axis, we will be preparing the curve of the best fit, and since we already have the value of our sample in turbidity, using the best fit curve we will be finding the concentration of sulfate for our sample. So in this way you can find the concentration of sulfate present in our sample. So after this you will be given the questionnaire based upon the video, which you will have to submit by the next week. Thank you.